Hey guys, this video is going to talk about how we graph quadratics in factored form. And again, if these videos aren't helping or you need additional help, then come chat with me before the test, preferably not like 5 minutes before the test. So here's factored form where we take a linear factor, some line, times another line, right? When we graph these, when we graph all quadratics, we really want to find that vertex point because the vertex lives on that axis of symmetry, right? So if we know where the axis of symmetry is, which is the vertex as well, then we know what's going on both sides of that axis of symmetry, which gives us a good understanding of the graph. Okay, so what we have to do in factored form is find, to help get at that vertex, what we can do is if we think about taking a quadratic in factored form and setting that quadratic equal to 0, which means we want our output to be 0, and then the question becomes what x values make it so that this function equals 0, right? So when we talk about equaling 0, we're talking about points that are on the x-axis because the output is 0. It's not positive or negative. So we want to find the x values that give us out a 0, which, in other words, we want to find the x-intercepts. Okay? Now, why these are important, the x-intercepts are important, is because let's say we found one here and we found one, say, here. Remember that these 2 points have the same output. We get out of 0 when you put in these x values. Okay? Therefore, they're reflection points of each other. So this technique of graphing quadratics, the intercepts become reflection points of each other. So therefore the axis of symmetry then has to be right in the middle of it, right? And remember, the way that we find in the middle of 2 points is average the 2 x values, whatever they happen to be, add up the 2 x values and divide by 2. So that'll give us the value of where the axis of symmetry is, which therefore is where the vertex lives. So once we get the value of where the axis of symmetry is, then we can plug that into our equation, see what we get out, and then we got our vertex, and then it just comes into plugging in some more points and plotting the reflections. So let's try this. So here is a quadratic in factored form, and let's graph this. So first thing that we're going to do is set our equation equal to 0, and we're going to find out which x values make this 0. So using the fact that 0 times anything is 0, we want to find out what x value makes this factor 0. And then also using the fact that if we can make this 0, 0 times anything is still 0. So that's our thought when we find our x-intercepts. So looking at this first linear factor, this negative x plus 2, we want to find out what x value makes this equal to 0, right? So when I look at this, I say, okay, this has to be, this negative x, or opposite of whatever number, has to be negative 2, because negative 2 plus 2 is 0. So if this has to be negative 2, this says take the opposite of whatever we put in, then x better be a positive 2. Because if x is positive 2, this becomes negative 2, and negative 2 plus 2 is 0. So if x is a positive 2, we're going to get out a 0. So that's a point that is on our graph. It's an x-intercept. So the point 2, 0, we get from the x value that makes this factor 0. Okay, looking at this one here, negative 2x minus 6, what x value makes this factor 0? So when I look at this, this has to be 6, because 6 minus 6 is 0. So what number do we multiply by negative 2 to make 6? Well, a negative times a negative is positive, so we know x has to be negative, and it's probably negative 3, because negative 3 times negative 2 is a positive 6. So if x is negative 3, that makes this factor 0, and 0 times anything is 0. So now we have our second point, negative 3, 0. Okay, perfect. So now we got our 2 reflection points, our intercepts. So let's find that axis of symmetry by cutting the distance right down the middle. So to do that, I'm going to average our 2 x coordinates. Let's add up our 2 x values, 2 plus negative 3, which has turned out to be negative 1, and then we cut that in half because we're adding two numbers. So this, x equaling negative 1/2, is going to be where our axis of symmetry is, right? So this line right here is our axis of symmetry. Okay? The vertex lives on that axis of symmetry at negative 1/2. So let's put in a negative 1/2 and see what we get out. See where that vertex actually is. So if x is a negative 1/2, that's what we're going to plug in for x, right? So everywhere in our function that there's an x, we're going to plug in negative 1/2. So what that looks like is we're going to have the opposite of negative 1/2, which is 1/2. And 1/2 plus 2 is 2.5. And we're going to take that number times what we get out in the other line when we put in negative 1/2. So a negative 1/2 times a negative 2. Negative times a negative is positive, and when you double a half, we get out 1. So this, when you put in a negative 1/2, we get out 1. 1 minus 5, or 1 minus 6, is negative 5. So let's see what 2.5 times negative 5 is. So if we double negative 5, we get negative 10. And then if we take a half of, that's what the 0.5, a half of negative 5, which is negative 2.5, we get negative 12.5. So our vertex is down here. So here's negative 10. It's a little bit lower than down here, right? So at negative 12.5, if I could go down there, I would. Maybe I can. Nope. Okay, so let's say that that's actually at negative 12.5. So now the next thing that we do is just plug in some points, right? Like what if x is 0? So again, all we're going to do is just find some extra input-output pairs that we know will be on the graph, and also its reflection. So let's let x, say, be 0. So we're finding out what f of 0 is. So if x is 0, we get the opposite of 0, which is still 0. 0 plus 2 is 2, times negative 2 times 0 is 0, and 0 minus 6 is negative 6. So if we put in a 0, we actually get out negative 12, which is just going to be half up from our vertex. So negative 12, its reflection also will be a 0.2. And then let's try another, let's try putting in a 1. So let's find out what f of 1 is. So everywhere there's an x, we're going to put in a 1. So we would get negative 1 plus 2, which is 1, times, if we're putting in a 1, this becomes negative 2 times 1, or negative 2. Negative 2 minus 6 is negative 8. So we would get 1 times negative 8, or negative 8. So if we put in a 1, we get out negative 8, and its reflection point, which is going to be right here, is also on the graph. Now notice the curve, it's opening up like this. So if we wanted to get a point up on top, let's put in either 3 or negative 4. Either one will work because one is a reflection of the other. So let's try 3. Put in a 3, this becomes negative 3. Negative 3 plus 2 is negative 1, times, if we're putting in a 3 here, negative 2 times 3 is negative 6, and negative 6 minus 6 is negative 12. And a negative 12 times a negative 1 is a positive 12. So when you put in a 3, we actually get out a positive 12, and so will its reflection here. If we put in a negative 4, we'll get positive 12. And now I'll try to connect these with my mouse. Not too bad. Oh, I jinxed myself. But there is our quadratic curve. Let's try one more. So here, let's find the values. Let's find our two x-intercepts, value of x that makes this 0. So this number here needs to be negative 2. So what number do we multiply by 4 so we can make negative 2? And the answer to that will be negative 1/2. So if x is a negative 1/2, that's right here. Okay, let's look at this one here. Well, this 2x has to be negative 4 to make 0. So 2 times what number makes negative 4? So x must be negative 2. So here's negative 2. So to find the axis of symmetry, let's add up our two numbers and cut it in half. So negative half plus negative 2 is negative 2.5. Cut that in half. So we're at half of a negative 2 is negative 1, and half of a half is a quarter. So negative 1.25. So that's going to be our axis of symmetry right through 1 1/4. So maybe like right there. Okay, so now we put in negative 1 1/4 into here, and we're going to end up getting negative 5 out, and negative 5 plus 2 is negative 7. So when we're putting in negative 1 1/4, we get negative 7 times, let's put in our negative 1 1/4 here. So if you double negative 1 1/4, we get back to negative 2 1/2. Negative 2 1/2 plus 4 is just 1 1/2. So negative 7 times 1 1/2, well, negative 7 times 1 is just negative 7, plus negative 7 times 1/2, and half of negative 7 is negative 3.5. So if you add those up, we get negative 10.5. So we know that at negative 10.5, so we can actually put the vertex just on the very bottom of my graph. So there's our vertex. Okay, so now let's put in some values. Let's try a negative 1. So if you put in a negative 1 here, 4 times negative 1 is negative 4. Negative 4 plus 2 is negative 2. So we're going to get a negative 2 times, putting in a negative 1 here, 2 times negative 1 is negative 2. Negative 2 plus 4 is a positive 2. So if we put in a negative 1, it looks like we're going to get out negative 4, and that doesn't seem right to me. Negative 1 times 4 is negative 4. Weird. Let's put in a 0 and see what we get. 4 times 0 is nothing, so we just get 2 here. 2 times 0 is nothing, so we just get 4. So 2 times 4 is 8. So if we put in a 0, we should get out 8. That looks good. There's still something a little fishy, I think, with my negative 4. 4 times negative 1 is negative 4. Plus 2 gives us negative 2. When x is negative 1, we get out negative 2. Negative 2 plus 4 is 2. Well, must be. Probably because that's a quarter unit away. Something seems fishy here, but I think our quadratic. Wow. Sorry, that was a horrible example there, but that is how we graph in factored form.